In this video, we're going to be looking at the standard that requires our students to represent constraints by equations or inequalities and by systems of equations or inequalities, and interpret data points as possible a solution or not possible a non-solution under the established constraints. The essential question is, how can I model constraints using mathematical notation? All right, and we set up 3 different math goals in order to satisfy the standard. The first one is to create a one-variable linear equation or inequality from the contextual situations. The second is to represent the constraints with inequalities. And the third, to determine if a data point is a solution or a non-solution. Our students are going to be required to complete all 3 of these goals in order to satisfy the standard. We're going to break down the standard using an example adapted from Lucy's linear equations and inequalities from the GeorgiaStandards frameworks. A rectangle is 12 meters in length. Its perimeter is less than 68 meters. Write an equation or inequality to represent the constraints of the problem. The first thing that our students are going to have to do in order to satisfy the standard is identify constraints. Now, these are just limitations or restrictions on the problem. So in this example, I identified our constraints as the 12 meters in length for the rectangle and that its perimeter is strictly less than 68 meters. The second part of the standard, they'll have to represent these constraints in either an equation or inequality, being that our perimeter is strictly less than 68 meters instead of equal to, we're going to use an inequality. So here I filled in our constraints, and after I solved for W, I got W is strictly less than 22 meters. So representing our constraints is just putting our constraints into the problem. Now, the last part, our students are going to have to test points to determine if it's a solution or a non-solution. So I gave the example W equal to 5. Well, since 5 is less than 22, and that is true, it is considered a solution. W equals 25, however, is not less than 22, so it is a non-solution. So the 3 things our students are going to have to do is identify constraints, represent them within the equation or inequality, and then be able to tell if it's a solution or non-solution by testing points. So now let's look at another example from the Georgia Standards of Excellence frameworks. When you go to GeorgiaStandards.Org, you can find a lot of resources to help you out when you're sifting through these standards. For this standard, I went to Algebra 1, and I went to Unit 2, and then I went to page 24. This is the acting out task from the GeorgiaStandards framework. This task is not only good for teaching the standard, it's also an excellent alignment for the standards for mathematical practice, Model the Mathematics. And it's because this task requires that students translate constraints into equations or inequalities and extract information from both the algebraic solution and the graphical display. In Part 1, students will create their graphical display, and in 2 and 3, they'll use that graphical display to determine the smallest and the largest distance that separate the actors' homes. In number 4, students will translate those constraints into a compound inequality and also graph the inequality. So this demonstrates perfect alignment with the Standards for Mathematical Practice Model in Mathematics because students will have to extract information from the graphic display in order to answer the questions in number 2 and number 3, and then also they'll have to use the constraints that are found in 2 and 3 to construct the compound inequality in 4. Next, you'll see students working on Part 1 in pairs. For this task, students working in pairs, small groups, or as a whole group can help each other clarify misconceptions and errors made within the task process.
I think what you should do is plot 5 points away from the center and then draw a circle around. Like, it's not going to be a perfect.
For the radius.
The radius, it's a 5-mile radius away from the center for area.
Okay, Stacey, do you understand why that's a better geometrical shape?
Yes, sir.
Why?
Because it shows, like, the total distance, like, at any given spot, not just certain little spots.
Along with mastering the standard in question, students are also able to work together in order to demonstrate the modeling of mathematics, which is one of your standards for mathematical practice. And they do this by extracting information from their graphical display in order to answer questions about the shortest and longest distance from the theater.
I think it's 8 miles.
I think it's 2 miles because that's the smallest distance.
Oh, the smallest. I meant the largest. I was thinking wrong. It's the smallest. 2.
All right, so what'd you guys get for the largest distance?
I think it's 8 miles.
So you just witnessed our students working together in the acting out task. Here's an individual work sample so that you can see how the students are able to demonstrate their ability to identify the constraints in question 2 and question 3, and also how they represent their constraints within an inequality in question 4. In the next video, watch as our students use their compound inequality from question 4 in order to test data points.
When we're doing this, we need to make some test points. All right, we need to make sure that something is a solution or non-solution. Okay, so I'm going to ask you some test points. All right, Stokes, looking at what you have, could they live 5 miles apart? And why?
Yes,
Okay, why?
because it's within 5 miles is between the 2 and 8 miles.
Okay. All right, Logan, looking at yours, could they live half a mile apart?
No.
Why?
Because their distance has to be 2 or greater, or 8 or less, and half a mile is less than 2.
Okay.
They can't live that.
All right. So Stokes, what about 10 miles?
No,
Why not?
because 10 miles is greater than 8, and the farthest distance they can live apart is 8 miles.
Okay, great. Thank you, guys.
It's important for our students to be able to test multiple data points in order to fully understand what it means to be a solution or a non-solution. So now that our students have identified constraints, represented constraints within an inequality, and tested data points, they have satisfied all 3 math goals and have met the requirements of the standard. In our last video, our students will identify misconceptions or possible errors that could have been made within the task or standard.
So what are some misconceptions that students may have when doing this activity?
Some students could think that they could count up a block, like 3, which is right, but then they count across the block 3, which is a completely different distance from sideways. They could count diagonally across the block.
Okay, and that's for finding the greatest distance, or what is that to find?
That's to find the points that for Kim, they could count from the theater and count diagonally across the blocks 3 times.
Okay, so the distance, and then that would give them some different kind of shape.
It would give them a square.
Your drawing didn't look like that in the beginning, so what are some misconceptions that happened with you during the first part of the activity?
In the beginning, I didn't realize that it was a whole radius. I was thinking that you had to go block by block, and it
Okay.
was the exact distance, not a whole radius of how far away it could be.